very good morning and good day to both of my panel 1 and panel 2, Encik Mazri bin Ibrahim and Encik Arman Adi bin Zahar. I am from Faculty of Electrical and Electronic Engineering Technology, and my name is Kuganesh Analagi Krishnasamy, and my matrix number is B07171050, and my supervisor name is Puan Nurul Ashikin binti Muhammad Rais. And today I am going to present about my final year project 2 presentation, which title was Design and Development of Efficiency Increase in Portable Vertical Axis Wind Turbine System for Lighting Application. This is my poster of my presentation, and the introduction was in this era of technology world, the wind technology is higher in demand, and so the wind power is best candidates among the wide availability. So the system is held to supply the free energy in form of kinetic to electrical energy. The usage of the system will be connected to the output as lighting application. The lighting is significant part in our life. There will be a competition between 3 light bulbs to record lumen brightness and for a fixed room scale. The installation for this system in housing area and campus area is a great way to lead transition to future of 100% clean energy and renewable energy. The objective of my presentation is to develop a prototype of the portable vertical axis wind turbine, and also to provide electricity from renewable energy for the purpose of usage of lighting a room system with size of 6 meters square, and also to compare the best light efficient from the low watt of LED bulb and compact fluorescent bulb and incandescent bulb. The methodology states that the design of this project is to create the wind turbine that absorbs the nominal wind drag force from the vehicle passing by roadway and produces electricity for the best chosen low watt lighting bulb for a small room scale. And the aim is to create the wind turbine that generates power then stored into 12 watt seed lead acid rechargeable battery, and the power transferred to light up the best energy saving light bulb. And the efficiency of the blades must be not exceed the BET's limit, which is 0.59, and its blades to be measured properly and also have to be lightweight materials. So as we see the flow of this methodology, the WAF wind turbine is combination of H rotor model and a 7S model, which has semicircular cylindrical shape to capture the drag force of this wind turbine and from vehicle passing by, and also drag force from the nominal wind speed. And when the drag force hit the blades, which attached to the rotor of the DC motor, it spins and the power is generated by the motor. The DC generator circuit then generates the electrical energy from the kinetic energy of the rotating rotating blades, which then transferred to the C lead acid, which is 12 watt and 8 ampere rechargeable battery to be charged. This mechanical energy is converted to the DC generated 12 watt into the electrical energy. If the charge is full, the charging will be cut off by the fuse of prevent overcharging of the battery, that it will be connected to the inverter circuit, which changes the over DC into AC as the battery is switched on, and the step-up transformer expands the the voltage required to the run and the run device. The MOSFET in the circuit is the transistor that manage the voltage, and the charge is powered afterwards. The best chosen energy efficient lighting with the fix of 12 watt and 18 to 24 watt, which is captured by the specific lumen, are the load of the final output of this project. This part shows the result of this project, which is the connection of the wind turbine system is placed on the two places, which is place A and place B. So the output result from the inverter circuit is shown in the poster and the proven result. So the initial output recorded was 82 volt and the maximum output recorded was 138 volt. Then the output result will be connected to the light ports for the recorded the lumen comparison between the types of light bulbs. And the data collection, as we can see, the system was placed at 2 different places in housing area and at 2 different timeline, which is day and night on the nominal wind speed. The main purpose of this project is to generate electricity to rural area for small quantities used such as lighting application at home or campus areas for lecture room scales. So we can see the reading of the voltage of residential place at 2 different timelines. The residential place chosen because the use of drag force from the wind produced by the vehicle passing by the roadway, and also drag force from the nominal wind current. And to the current generator power, the place where most car passing by the roadway, they were used to batteries because used one for data collection in a day or and another for night. Okay, the comparison of voltage gain, the graph shows that the test 1, test 2 and test 3 is taken from 3 times, which is to gain the average reading of the voltage gain at the place A and place B is can be seen. The place B is the higher in the voltage gain. So the voltage gain by the power supply is around 2 volt and each every day to store the into the battery. And the comparison of the lumen, the reading, the three graphs above shows that the voltage reading taken from the watt power generation by nominal wind speed on weekend timeline. The graph shows that the wind speed is much higher during night timeline. In this test 1, 2 and 3 shows that the proof that the power generates is above 0.4 volt, and during daytime the wind speed is literally slow and not too much wind collected. There are also a different two types of places used to take the power generation in this house area. The place B, which is on top of the balcony of the house, and prove that the wind speed higher compared to the place B, which is on corridor of the house. So the wind speed is needs higher place to generate easily. The table shows the location distance in a room, which is three parts, which is upper, center and lower. So for LED of 18 watt, we can see the upper area distance. The lumen which can be produced is 1713, which is the capability around 1600 lumens. And its center, it can be captured 1445, in lower the 543. So in CFS it shows the 1400 in upper part and 709 for center and lower 340. Incandescent shows that 338 for upper and center is 84 and for lower is 44. So it states that the LED is best for the lighting application for the 6 meter square room scale because of its low voltage bulb, and it can be give the higher lumen for a small room scale. The warp system is used to start up the lighting bulb, and the result the comparison between the bulbs. So the lighting application lumen were recorded for the LED and CFLs, and incandescent bulb will use mobile application lux meter. The application can give a reliable measure illumination and light intensity level for measures the differences between the different types of light sources. And then at last the result states that the output result actually the main reason to start up the lighting application. This system is clearly states that it can capable to start up a lighting system with 230 volt and 12 watt to 20 watt bulb type of bulbs. The lighting efficiency points that the LED have a higher capacity of lumen compared to the two other light bulbs, which is compact fluorescent and incandescent bulb for a standard room scale of 6 meter square. From this project, the conclusion states that the studied wind has a lot of potential. It is, if properly harnessed, it can help solving the energy crisis in the world. A wind turbine is a machine that converts the wind into the kinetic energy into the electricity. In this project, this conclusion, the power output from the wind turbines is proportional to the area swept by their blades and to the cube of the wind speed. Then the three types of low watt bulb was tested and recorded for the lumen reading for the chosen best light efficient for the small room scale size. As a result, the low volt bulb gain, the output gain from this system is the LED is the best efficient bulb compared to the other two bulb, which is compact fluorescent and incandescent bulb. This product is also more user friendly and the natural energy can be utilized effectively. To present about the project demonstration. This is the valve system that I was designed and demonstrate during daytime. So first of all, I test the output voltage from the wind turbine. The output of the wind turbine will be connected to the DC generator bridge. and which shows 7.4 some 4 volt with gain. It will helps the battery will help the blades to move, and the excessive of the battery voltage will be charged from the blades, rotation of the blades. And the DC generator bridge rectifier circuit acts as a help of to store the input power to create the from the wind turbine into the rechargeable lead acid battery. And the inverter circuit converts the DC electricity source from the battery to AC electricity, and it is showed output of the transformer around 26 and above voltage. So after the connection into the MOSFET drivers, it will be light up the lighting ports with the measurement of the multimeter, with checking the volt, the output volt of this project. The output of this project will be around 126 to 186 volt.